When you look at your everyday batteries, you will notice that they have different sizes, but roughly the same shape. A battery uses a chemical reaction to produce electricity and power your circuit, whatever it may be. Commonly, batteries are used in DC circuits, called direct circuits. The source of these circuits, for our purposes, is a voltage source. The basic battery, like a AAA, AA, C, and D battery, are all 1.5 volts per battery. That is just the way it is. Making a battery is beyond the scope of this course, and beyond my expertise. Thus, I will not be able to tell you how to make a battery. For an easy demonstration, voltage is like the diameter of a garden hose. It will regulate how much current, which is the water, can pass through. The current is the force of the water coming out of the hose. The higher voltage always has the potential for a higher current. Sometimes it is necessary to bring the voltage rating down on a component. Sometimes, if we do not do this, we will fry the component we are working on. To do this, we will wire the resistor in front of the component. Now the question is, what value resistor do I need? There is a law in electrical engineering that is the most fundamental law of the profession, Ohm's Law. A variation of it is voltage equals current times resistance. If you need to find the value of a resistor, use algebra to rearrange the equation. In that case, to find the resistor value needed, we need to know the voltage and the current of the circuit. The current will be whatever the component is rated as. If I am trying to wire an LED that is formally amps, which is 0.004 amperes, and the battery voltage is 1.5 volts, we can find the resistor necessary so that the LED doesn't fry. Use Ohm's law, plugging in the numbers known, to find the value of the resistor. If you did the equation correctly, you need the 375 ohm resistor. This value is fairly common for a very basic circuit, and you should be able to locate the resistor at an electrical store such as Radio Shack. Be warned, I do not trust that company because of their lousy service and ethical problems. Make the call yourself. If you cannot find a resistor exactly 375 ohms, that is okay. Find one that is as close as possible that is a value greater than 375. Any less will damage the component. It is that easy setting up the circuit. Now that the LED is installed with a resistor that won't blow it up, all we need to do is wire a switch into the circuit. There are many which simply turns the circuit on or off. The switch itself should have an insignificant amperage drawn. The actual boot work will be done in the next course. When working with electricity, whether it is from the wall or not, we need to focus on safety. Electricity is not to be feared, but respected. There are a couple of basic rules you need to follow as a hobbyist. Number 1. Never attempt to measure the resistance of a battery. Number 2. When working on a circuit, always kill the power by turning it off. Number 3. A short circuit will damage components. Be careful. Number 4. Small hobby stuff isn't likely to cause catastrophic consequences. A little smoke might come off the component, or it will become warm and fail. Typically. Number 5. Always work with proper ventilation. Number 6. Always ground yourself. This means touching any piece of metal that is connected to the floor or ground. This dissipates any static shock that is built up on your body. Failure to safely discharge this static can damage the circuit, because the components are very sensitive. Releasing static shock is like blowing negative 50-degree winds at a Galapagos turtle. It won't survive. The ground is just that. In a free-floating circuit, the ground returns the loop around back to the power source. When you plug something in the wall, notice how there are 2 or 3 prongs. One of those is a neutral, also known as your ground wire. It connects to a pipe or wire, typically in your basement or next to the circuit breaker, and it is connected literally into the ground. Electricity needs to go somewhere, and this is important if and when we discuss capacitors. For that reason, Never open appliances unless you know what you are doing. When you are wiring components, everything typically has a positive and negative wire. The negative wire, by convention, is usually longer. Sometimes there will be a third bracket in the middle. This is normally for your ground if necessary, out of our scope, or for connecting other components a little more advanced. We'll get to it. I think that about does it, at least on the theoretical side. Next we will look at more advanced topics such as boot work and the difference between series and parallel circuits. No exams. Go out and do what you need to